The text-only ChatGPT interfaces that we all use basically every single day.
Oh, yeah, the standard chat box.
Yeah, exactly. They are, believe it or not, already obsolete.
Right.
I mean, they're essentially the 1980s MS-DOS command line of this whole AI era.
That is a really great way to look at it, actually.
Right. Like, they're incredibly powerful if you know the exact syntax to type into a blank screen, but they are completely unready for mass adoption. We are moving out of that command line phase and into the visual sort of Windows or Mac era where all UI is fundamentally becoming AI.
Yeah, because, building a highly capable artificial intelligence model under the hood, that was just the first challenge.
Right, the plumbing.
Exactly. The new hurdle for developers is building an interface that doesn't just, spit out a massive wall of overwhelming text.
Nobody wants to read 4 paragraphs of text to get an answer.
No, not at all. People want an interface that returns actual actionable elements. We're talking visual reports, interactive charts, and complex approval forms that are rendered dynamically on the screen based on what the AI decides is, well, most useful in that specific moment.
Okay, let's unpack this. Because if you, our listener, are looking to gain knowledge quickly without being buried in information overload, this deep dive is basically your shortcut to understanding that exact evolution.
Yeah, we've got some great material today.
We really do. We are exploring the cutting-edge architecture of modern AI interfaces, and we're drawing from a really comprehensive course. It's called L0 Generative UI Evolution and Approaches.
Taught by Atay Barkai over at CopilotKit.
Exactly, alongside AI pioneer Andrew N. So our mission today is to explore how developers are fundamentally rebuilding the way we interact with software, layer by layer.
And to understand how we actually reach this visual era of AI, we first have to look at why the existing software plumbing is just completely broken by modern AI agents.
By broken out.
Well, standard software engineering has relied on a really rigid request and response model for, decades.
Right.
You ask a server for data, and it hands it back in a clean, closed loop. Agents completely shatter that paradigm.
Because they aren't just, blindly fetching data. They are actually thinking and operating independently.
Exactly. They are these long-running processes that stream data continuously. They require mid-run steering from the user, and they often hand off tasks to autonomous sub-agents in the background.
Wow.
And crucially, their UI choices are non-deterministic.
Non-deterministic, meaning they don't do the exact same thing every time.
Right. The agent itself analyzes the context of the conversation and decides on its own what interface components need to be rendered. So trying to put a dynamic, non-deterministic agent behind a traditional, rigid API, it forces developers to rewrite decades of glue code. It just creates massive bottlenecks.
So let's ground this for a second. If standard programming is like a vending machine, you push a specific button, you get a specific soda. An agent is much more like a sous chef. The sous chef might start chopping vegetables, then pause to ask you a clarifying question about the menu, hand off the sauce to a line cook, and stream their progress to you all at once.
That's exactly
That
it.
completely breaks the vending machine model. You can't just press a button and walk away. So how do developers actually fix this communication breakdown?
Well, if we connect this to the bigger picture, the industry is solving this with a new architectural standard called the protocol triangle.
Okay, protocol triangle.
Yeah, one leg is MCP, which connects agents to their tools.
Right.
Another is A2A, connecting agents to other agents. But the crucial third leg, the one solving our specific UI problem, is AGUI.
AGUI.
Right, the Agent User Interaction Protocol. This is a framework-agnostic, event-based standard, and it's being adopted by major players like Google, Microsoft, and Amazon.
Wow. Okay.
It basically standardizes how chat messages, tool calls, and streaming tokens flow over HTTP, regardless of what language the application is actually written in.
So it acts as this sort of universal translator between the smart AI backend and the visual front end.
Exactly.
The course mentions we've got this 3-tier architecture making it work in practice. So the backend is your server where the actual agent lives, right? Like a LangChain environment or maybe a Google Gemini model.
Yep, that's tier 1. Then sitting in the middle is the Copilot runtime.
Okay.
This is a middleware server, often running on something like a ONO server, that acts as a secure registry. It handles authentication, manages the state, and deals with scaling traffic.
Got it.
And finally, tier 3, the front end. This is usually your React application, wrapping the entire user interface in a specific CopilotKit provider that listens to that middleware. And this hard separation of concerns creates an incredible superpower for developers.
Oh, because you can hot swap an entire AI backend instantly
Yes,
without
instant.
touching the visual UI code at all. You just like change a single string, I think it's an agent type variable in React Frontend to point from one model to another, and that middleware just routes it perfectly.
Exactly. The front end doesn't even realize the brain of the operation was entirely swapped out.
That is wild. Okay, so once that AGUI middleware is translating everything, how do we actually build the visual UI components that, pop up on the screen?
Well, you essentially have a spectrum of control.
Okay.
And it starts with what developers love most, which is absolute lock and key control. They call this controlled generative UI.
Control Gen UI. So this is the safest end of the spectrum.
Oh, yeah. This is the workhorse approach. It's the 80-20 solution used for core product features where visual consistency is absolutely mandatory.
Right, like you can't have the AI messing up your main dashboard.
Exactly. So using a specific hook called use component, developers basically handcraft highly secure custom components.
Like what?
Imagine a highly stylized pie chart or a...
It strictly defines and validates the exact parameters the agent is allowed to pass in. So it physically stops the AI from, passing a random string of text when the component explicitly requires an integer.
Exactly. And the workflow here is fascinating because the agent never actually sees the React code itself.
Really?
Yeah, the AGUI middleware converts your custom UI component into a standard tool definition that the language model understands.
Okay, I'm following.
So when the agent is processing a request and decides, oh, the user needs to see that flight card, it executes what's called a Frontend tool call.
Okay.
That call halts the backend AI, hands execution back over to the front end, and lets React render a pixel-perfect, completely brand-compliant UI natively right there in the browser.
Which totally prevents hallucinated UI. I mean, the agent is strictly bound to only call validated pre-registered tools that the developer explicitly built and approved.
Exactly. It's very safe.
That sounds bulletproof for core features, sure. But let's look at the scale of a modern application. I mean, if a platform has 200 distinct features, hand-coding 200 individual bespoke components just so the AI has permission to use them, that sounds like a massive bottleneck.
Oh, it is.
I mean, that linear scaling is a nightmare for a development team trying to ship fast.
You've hit on the exact limitation of the controlled approach. It scales terribly for the long tail of edge case user requests.
Right.
And that brings us to the next step up the generative UI spectrum, which is declarative generative UI.
Okay.
This leverages an open specification originated by Google called A2UI. Instead of building monolithic, hard-coded components for every single possible feature, developers define 3 separate pillars.
So if I'm getting this instead of a finished house, you're giving the AI the raw materials, the wood, the nails, and the blueprints.
That is a perfect way to put it. First, you provide a component catalog. These are platform-agnostic definitions of basic building blocks paired with your brand's specific renderers. Second, you provide a schema. This dictates how these blocks are allowed to nest together.
Like rules.
Exactly. For instance, ensuring a row can contain an image and text, but it cannot contain another row.
Makes sense.
And third, data bindings. These are the actual runtime values that the AI injects into those blocks.
Here's where it gets really interesting. Control Gen UI is like giving the AI a fixed restaurant menu. It can only order the number 4 combo exactly as pictured.
Yes.
But declarative Gen UI is like giving the AI a giant bucket of Lego blocks. You provide the verified blocks and you let the AI snap them together on the fly to build whatever it needs to answer the user's prompt.
And those Lego blocks can be assembled in 2 distinct ways.
Okay.
With a fixed schema, the developer still arranges the blocks in advance. The agent just fetches the data to fill them in.
So still pretty controlled.
Right. This is best for high-traffic surfaces like a polished flight results page, where structural consistency is absolutely non-negotiable.
But then there's a dynamic schema.
Yes. With a dynamic schema, the agent acts as the architect. It chooses the components, builds the layout, and fills in the data entirely on the fly. This handles the long tail of internal applications beautifully. Let's say a user asks a custom sales dashboard to show Q3 revenue next to churn rate.
Okay.
The agent just snaps together a bar chart block and a text block in a layout the developer never explicitly designed, but that perfectly answers the question.
That is amazing.
Yeah.
So we're moving from a rigid menu to Lego blocks. But what happens when the user asks for an experience completely outside the Lego set?
Well, then we reach the far end of the generative UI spectrum. This is where the constraints are removed entirely.
Okay, brace yourself.
We call this open-ended generative UI. By flipping a single Boolean flag in the code, literally just setting open generative UI,
Right.
the agent is granted permission to write and render arbitrary HTML, CSS, and JavaScript from scratch, entirely on demand.
Wait. If we let the AI write raw code on the fly and render it directly in the user's browser, aren't we inviting total chaos into the app?
Well,
I mean, the source material actually mentioned a user asking the AI for raining tacos. If the AI can just generate a script that makes animated tacos fall down the screen, how do you maintain any sense of product consistency or even performance?
right. Well, this raises an important question about trade-offs.
Yeah, I'd say so.
When you grant absolute freedom, you definitely sacrifice predictability and speed. Generating raw code requires a massive amount of what we call thinking tokens.
Thinking tokens.
Right. The model has to reason through the entire DOM structure, the CSS classes, and the logic layer from scratch, rather than just selecting a predefined JSON object.
That sounds heavy.
It is. Because
Wow.
it processes so much more information, it is the slowest, most computationally expensive approach on the entire spectrum. And yes, it is highly sensitive to prompt phrasing, hence the raining tacos.
The tacos.
Right, so it's strictly reserved for boundlessly custom, highly delightful experiences on the late long tail, where that novelty outweighs the need for strict consistency.
Okay, but there is an alternative, though, for that open-ended side of the spectrum, right? A way to get infinite flexibility without relying on the AI to hallucinate raw code.
Yes, there is.
Instead of generating a UI from scratch, you can use MCP apps. So this leverages the Model Context Protocol. And the philosophy here shifts to bringing the app to the agent.
Exactly. You connect the agent to fully featured existing third-party applications.
So if a user asks the agent to draw a complex system architecture diagram, the agent doesn't try to, write raw HTML canvas code.
No, that would be a mess. Instead, it opens an instance of Excalidraw, a dedicated whiteboarding tool directly inside the chat interface. You get the full power of Figma, HubSpot, or Excalidraw instantly.
That sounds incredible, but embedding a complex third-party application directly into my app's front end, just based on an AI's whim, sounds like a major security vulnerability.
It's a valid concern.
How is that actually sandboxed so the AI doesn't, break the parent application?
So the architecture relies on an MCP server that exposes the third-party app. Your front end acts as the host, embedding that app inside a highly secured double iframe.
A double iframe.
Yes. The double iframe creates this strict, impenetrable boundary. It prevents the embedded application, and by extension, the AI from accessing the parent Windows DOM, the user cookies, or local storage.
Okay, so they can't cross-contaminate.
Exactly. They communicate strictly via JSON RPC. It's a lightweight remote procedure call protocol that only passes authorized messages across that boundary.
A secure, isolated sandbox.
Yes.
But I mean, running an entire application inside another application, constantly passing messages back and forth, that introduces a lot of indirection overhead, doesn't it?
Oh, absolutely. You're trading memory and performance for ultimate flexibility.
Right. So we have this full spectrum now. We have controlled components for core features, declarative Legos for the dynamic middle ground, and open-ended code or MCP apps for infinite possibilities.
Okay.
But, as long as this AI is trapped inside a little chat box on the side of the screen, it still feels bolted on. It doesn't feel native to the software.
And breaking the agent out of the chat window is really the final frontier this material addresses.
Okay.
This is where we move into full-stack Canvas applications, with tools like Cursor or Notion AI really leading the way.
Yeah, I love Notion AI.
Right. And a truly agentic Canvas app has 3 non-negotiable qualities. First, intuitive UX.
Meaning what?
This means augmenting text chat with voice, video, or generative UI right there in the main workspace, not hidden away in some sidebar.
Makes sense.
Second, the agent is a native entity. If a user can click a button to perform an action, they should be able to ask the agent to do it, and vice versa.
So it has to have the keys to the car.
Exactly. And the third quality is deep real-time context.
Okay.
The AI must continuously know exactly what you were looking at and what actions are currently available. To achieve this, we need front-end tool calls, which are those actions executing directly in the React front-end via that use front-end tool hook, and crucially, shared state synchronization.
Shared state. Okay, so what does this all actually mean? Standard chatbots are kind of like communicating via walkie-talkies.
Yeah.
You say your piece, you say over, the bot thinks, and it replies.
Yep, turn-based.
But a Canvas application with shared state is like you and the AI standing side by side at a shared whiteboard. You both see every marker stroke in real time.
That is exactly the feeling.
But let's look at the bidirectional to-do list application from the source material.
Yeah, okay. Yeah.
If the backend is maintaining the master list of to-do items, and my front end is subscribed to it using a useAgent hook, what happens if I manually check off a to-do item on my screen at the exact same millisecond the AI decides to update that same item from the backend?
Right.
Who wins? It feels like they would just overwrite each other and crash the whole app.
And that potential for race conditions is exactly why the AGUI middleware is so critical. Updates aren't handled by manual data polling, where the front end constantly asks the server for the latest version.
Okay.
Instead, updates are natively streamed as state delta events in both directions simultaneously.
State delta events. So it's only sending the specific microscopic changes, not reloading the whole list.
Exactly. The AGUI middleware basically acts as a traffic cop. If you check a box and the AI simultaneously edits the text of that same item, the middleware resolves the conflict by mathematically merging those specific state deltas.
Wow.
Yeah. Any edit you make is instantly integrated into the agent's context window for its next turn, and any action the agent takes instantly renders on your screen. It completely eliminates the disconnect between the agent's internal memory and the user's visual interface.
It's an incredibly elegant solution to a really chaotic problem.
It really is.
So if we synthesize this whole journey, the overarching reality is that there's no single approach that rules them all. It is a mix-and-match ecosystem.
Absolutely.
You can build a system with a pixel-perfect controlled component for the core dashboard, a declarative Lego layout for internal employee tools, and an open-ended sandbox for highly novel requests, and have it all seamlessly synchronized over a shared state architecture.
And because it's built on open standards like AGUI and A2UI, it is designed to interoperate across the broader agentic ecosystem. So developers aren't locked into a single proprietary framework.
Which directly serves your goal as the listener of avoiding information overload. The next time you use a cutting-edge tool, you will instantly recognize the underlying plumbing.
Yeah, you really will.
You'll see a pristine flight card and know you're looking at controlled Gen UI. You'll see a dynamically assembled dashboard and recognize the declarative Lego blocks at work behind the scenes. You now have the mental model to understand exactly what layer of the spectrum developers are utilizing.
And, this deep dive only covered the first layer of the future agentic front-end stack, which is interactivity, providing the UI and the shared state.
Right. What comes next?
Well, as applications scale into massive production environments, developers will build out 3 more layers. First is persistence, which focuses on efficiently storing these rich, dynamic interactions.
Okay.
Then comes insight.
Insight is fascinating to me because traditional UX analytics completely fail when the UI is generated on the fly.
Oh, totally.
Like if you use a heat map to see where users are clicking, but the layout is entirely different for every single session based on the AI's dynamic schema, that heat map data is functionally useless.
It's garbage. It requires entirely new paradigms for analyzing user behavior in non-deterministic environments.
Right.
And finally, the most advanced layer, self-improvement.
Oh boy.
Enabling agents to autonomously learn from these interactions across various sessions, independently optimizing their performance and their UI choices over time based on those new analytics.
Self-improvement.
Right.
That leads me to a final sort of mind-expanding idea built purely on that projection.
Let's hear it.
If agents eventually learn to autonomously analyze and improve from our interactions, will the concept of a standard user interface disappear entirely? Think back to the MS-DOS era we started with. The interface was static. Everyone saw the exact same command line.
Right.
But imagine a future where you log into a web application and there's no hard-coded UI at all. Instead, the generative AI instantly builds a bespoke layout, customized exactly for your personal cognitive psychology, your specific workflows, and your visual preferences in that exact moment.
That is wild.
A web where no two people ever see the same interface again. Something to mull over until next time.